Hey everyone, I hope that you can all see my screen now. Right? So, okay. So, who all we have right now? We have, okay, Akash, Moksha. See, I'll not be able to remember your names, but my name is Aparna. So please come back with your doubts, whatever you have during the session, right? So as per communicated right now, recently, that we all have been done with the OSI model, IP addressing and submitting, right, everyone? So please be responsive during the online session. I don't want any kind of the silence in my session. I don't know your names, but please come back with your responses. Make this session interactive, right? Everyone.
Okay.
Okay. Okay. So what is the role of the transport layer? What is the role of the transport layer? Malla Mukesh. What is the role of the transport layer in OSI model? Malla Mukesh, are you there? Molly. So okay, anyone can tell me what is the role of the transport layer? What is the role of the
Segment
transport layer? Yeah. Yes, Kalyan. Please tell.
in the transport layer, the segmentation will take place. How the data will be converted into small bits.
Right. So what is the header? What is there which happens in the transport layer which converts the data to segments? What are the important parameters which gets attached to make it as a segment? What is the header? There has to be some identification to mark that, okay, that this particular thing belongs to transport layer. Or see, every time a PC sends a packet to any destination, it attaches certain things. So at the transport layer, what it attaches? Kusumlata. Jeevan. Shivana. Shruti. Nobody knows. Did I take it as no one knows? Okay, how many layers are in OSI model? How many? Yeah. Tell me. Yes. Go ahead. Yes. Topmost layer. Topmost layer. Application. Next layer.
Presentation.
Very good. Next layer.
Session layer.
Session layer.
Session layer, ma'am.
Next. Very good.
Transport layer.
Export. Very good. Next layer.
Network layer.
Good.
Data link layer. Physical layer.
Very good.
Physical layer.
Data link layer. Physical layer.
Very good. Good. Very good. Application. See, application. Just a revise, please. It is very important because probably down the lane after some years you are going to place on some kind of a network profile which includes troubleshooting or which includes the implementation part. So you should know that how the packet is flowing from the source to destination. So user interface is user, a raw user like you can see google.com, you can see transfer this file, you can see open a website. User, plain user. As a technical guy, I know what is happening at the back end. How what a user can see, that is can be a raw user. Now what happens at the presentation layer? Yes, anyone? Understand the header part here, very important. Presentation. What happens at the presentation? Yes, anyone? See, this is what a user as well as a PC both can understand. Can a user understand this presentation layer? If I will ask you that what happens
Encrypt and
to my data, what will be your answer? Yes, yes, go ahead, yes. Yes. Presentation. This is used by a PC, not by a user. Why? PC understands zeros and ones. PC is a device which has to convert that data to his intelligence so that he can understand what a user is giving, what a raw user is giving. So he is converting into his own presentable form so that I can understand. Got it, everyone? Encryption and compression. Encryption, have you ever heard ASCII, EBCDIC codes? Everyone? Have you ever heard about these codes?
Yes, ma'am.
Yes. So this is very much belongs to PC. They uses this device to encrypt the data so that these codes will be understandable by a PC. Compression. If the file size is large, it compresses by on its own without giving you any notification that the file has been compressed. Okay. So I am at a source PC, right? I have to go to a destination PC, right? Session layer. Session layer, I know that you guys will say it establishes the session. But as of now, my source PC is aware about the source IP. Source MAC, no. Source IP will be assigned at this layer. Source MAC will be assigned at this layer. As of now, no destination IP, no destination MAC. So what the session layer will do? It will create the different sessions of different applications. Let's say you have tried accessing google.com. You have tried transferring a file to a particular server, let's say who might be sitting at something. You have opened a YouTube page. So you have opened 3 different sessions. So it will create 3 different session IDs, session ID 1, session ID 2, session ID 3, just for its internal purpose. That, okay, I have 3 different applications and I'm going to name it. If it is Linux system, these are created in the socket IDs. So it is an open standard format, right? Transport layer, responsible for the transport. I asked you this question, what happens at the transport layer? So one of you told me that segmentation happens. So why segmentation happens? What is segment? Do you know segment? What is it? Till here, it's a raw data. Till session layer, it's a raw data. Now transport layer is responsible. Your answer should be for the reliable. You guys are not studying, I think. Reliable and unreliable delivery of data. You all have done this. See, I never wanted to waste my time here, but since I have to start with the switching and these are very important parts, before I start with your switching, I cannot let it go like that. So if you are not studying, it's your loss. I'm telling you 100%. You have to study whatever is being explained in the session. It's only 2-hour session. Just go back and revise all the concepts. You have a full week with you. Everyone.
Yes, ma'am.
Yeah. Reliable and unreliable. That means whatever I'm sending, I'm getting an acknowledgement. Reliable. Whatever I'm sending, should I get an acknowledgement? No, I don't need. Like, example, unreliable. I'm speaking. Everyone will start saying, we got it, we got it, we got it, Aparna, we got it. So what will happen? As a result of which, you will not able to understand me. I will not be able to understand you. So wherever there is a flooding of the packets, it's unreliable. Don't send any acknowledgement. The packet is transmitted, it's fine. If I have skipped listening something to you, you can come back to me. Aparna, can you please repeat? I have not understood. But if you have any problem, if you don't have any problem, You will keep on listening in silent mode. Okay, I got it. I got it. I got it. But you never going to come back to me and say that Aparna, I got it. Do you get it?
Yes.
Good.
Yes, ma'am.
Right.
Yes, ma'am.
See, whenever the data lands on the transport layer, the data is being attached with a couple number of the parameters, and that's what is segment. That's what I have asked you. So I know I have been asked to teach you switching from today, but I cannot go ahead like this, right? So I have to make ensure that you know all these things, because these are going to be a part of the troubleshooting in switch. The transport layer adds what? Very main two important things is the source port and destination port. Do you know what are port numbers? Everyone? Do you know what are port numbers? Anyone knows? For the people who are sitting here? Port number. See, every application has a dedicated port number assigned to it. That's how that's here it becomes a segment. This is segment. So if you are saying segmentation happens here, that's how the data gets attached with a lot of parameters. Like what I have to do? I have to go to open a website. What I have to do? I have to go and transfer a file. What I have to do? I have to remotely log in. It depends upon the application port number, which I tell to my PC, okay, you go and do this. So that whenever it goes and do this, it goes to the switch or probably a router or probably to a device who understands, okay, it has to be done like this with a packet, right? You get it? Everyone? So what are port numbers? Port numbers are for the identification of application. Can anyone tell me what type of the applications you have? You know? www, one application, everyone. HTTP, HTTPS, DHCP, DNS, Telnet, SSH. This you know or not? Tell me.
Yes, ma'am.
You know. Do you know how to give a static IP to a PC? Let me come down onto a very raw level. You have done IP addressing, guys. You know how to give an IP address to a PC?
Yes, ma'am.
Good. So that is again a protocol. That is a BOOTP protocol through which you are giving, that enables you to give an IP to the PC. Okay. If it is a TCP application, we have an acknowledgement number, because for every segment, I get an acknowledgement. It is sequenced. The data is there, CRC check is there, source port is there, destination port is there, and I'm good. This becomes a segment. Now, very important thing, port number. So let me write down the applications. I have couple number of the applications. If you say www or HTTP, port number is 80. Please write down. HTTPS, I will ask you, I'll keep on asking you in my every session. I don't know what you have done till now, but I'll not go ahead until or unless you don't answer me the things which I want. 2021. FTP is file transfer protocol. Anything wherever you don't understand anything, please Stop me in between. I will explain. No problem. Rajiv sir, are you there?
Yeah, I'm here.
तो आपने इनके साथ कोई पीडीएफ शेयर करा है?
पीडीएफ तो नहीं किया इनके साथ शेयर कोई अभी।
अच्छा,
मटेरियल अभी दिया नहीं है, मटेरियल देना था वो एक्चुअली सुमित को ना, फिर वो
अच्छा
तो
सुमित
जो
कर रहा था
प्रैक्टिकली पढ़ाया है और वीडियो का रिकॉर्डिंग है उनका लिंक दिया है बस।
अच्छा, तो मैं इनको एक पीडीएफ दूंगी, आप बेशक इनसे
कोई
शेयर
दिक्कत
कर
नहीं, मैं शेयर कर दूंगा। हाँ ठीक है।
है ना? ट्रिवियल फाइल ट्रांसफर प्रोटोकॉल, टीएफटीपी। और कौन सा एप्लीकेशन होता है? डीएचसीपी। व्हाट डीएचसीपी डज? डीएचसीपी क्या करता है बच्चों, बताओ फटाफट। व्हाट डीएचसीपी डज इन द एनवायरनमेंट एवरीवन?
Dynamic
Dynamic
host
host configure.
Very good. See, the things which you know, please come back as quick, because the more quick you will respond me, my level of explaining you and taking you all forward will be much better, right? Otherwise, if you will not respond me as quick, my speed will be slow, the syllabus will be covered slow, and it all depends on you, right? So DHCP port number 6768. What else? DNS. What is DNS? What DNS does?
Domain name.
Very good. What is port number? Is 53. It dynamically assigns the IP. It dynamically assigns the IP to all the PCs. Just wait. Give me a sec. Just wait. Just wait, guys. So yes, sorry. So DHCP is dynamically assigning the IPs to the PC, and the port numbers are fixed by IEEE. Domain name server is a port number is this, and it maps IP to name and name to IP. Right? What else? You can please write down the port numbers. I will share this white paper with you. What all protocols do we have apart from this? This is responsible for transferring the file more than 20 MB, right? This is responsible for, again, trivial file transfer protocol, which is less than 20 MB, right? So it is a stripped down version of this file transfer protocol. There are a lot of protocols like this, but these are the main ones. And there is one more, telnet. Port number is 23. It is a remote login, but not encrypted. SSH is a secure shell telnet. It is an encrypted remote login. Encrypted remote login. This is port number is 22. So please remember these port numbers. Apart from this, there are whatever applications you have port number associated with it. Whatever applications you have. If you have an application, it must have a port number for the identification, because a PC who's going to do www.google.com, or a user, how can he tell the other device that I have to go to Google or I have to go to www? So it will build up the packet based on this OSI. This PC will put the data in the application, encrypt the data, compress the data, give that data a session ID, give the data a source port number and a destination port number, and becomes a segment. So now the segment goes to the network layer. What happens at the network layer? Everyone.
Segments are converted into packets.
What happens at the network layer? Yes. Who's going to respond me? What happens at the network layer? Nobody speaks anything here.
Segments are converted into packets, ma'am.
How will I deliver the session like this? You have studied OSI model. You have studied IP addressing subnetting, and you are not responding.
Madam,
Breaking up segments into networking packets.
How will we go ahead with our switching in that case? The routing happens here. IP addressing happens here. Network layer. IP addressing. What happens at the data link layer?
The addresses.
Hardware addressing happens here, or MAC addressing happens here. What happens at the physical layers? Zeros, ones. Media. Cabling. Doubts? So basically, what happens here? A source PC, you will say www.google.com. Right? What will happen? This is a raw data. Right? See, this google.com has an IP. This data got encrypted, compressed at the presentation. This got a session ID number 1 at the session layer. Now, till here it is a data. At the transport layer, this data gets encapsulated with the source port number, destination port number, and it becomes a segment. Now, this segment or data again gets encapsulated at the network layer. What? With a source IP and destination IP, and it becomes a packet and still at the source PC. This packet or data comes at the data link layer, gets encapsulated with the source MAC and destination MAC, and becomes a frame. And finally, zeros and ones. It goes via media, goes to the destination PC. It will decapsulate the destination MAC. It will decapsulate the destination IP. It will decapsulate the destination port number. It establishes the session ID. Here it establishes the session. It decrypts the data, decompress the data, and your application gets it. This is how the OSI stacks works. This is the flow. This is the flow, like the application is opening. And here the session is established. Do you get it? Everyone?
yes, ma'am.
Do you get it? No response. Do you get it?
Yes, ma'am.
Are you getting this or not? Segment, packet, frame, zeros, ones. I'm waiting for the response.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everyone got this or not? Come back. Okay, do one thing. I'm going to give you a question on IP addressing. 192.168.10.0/27. Can you please tell me the subnet mask? You have done subnetting, right?
Yes, ma'am.
Can you please tell me the subnet mask of this? Anyone? Very good, Parimal. Okay, going ahead. What are the number of subnets? Number of subnets. And number of hosts per subnet. And what is the broadcast ID of the first subnet? See, I cannot proceed ahead without routing and switching concept, with the routing and switching concepts until or unless you are not clear with this.
Ma'am, subnet mask is
Mm-hmm.
255.255.254, ma'am.
224. Right, okay. Next.
Number of subnet is equal to 8, ma'am.
That
Number of subnets.
8, ma'am.
Very good. And number of hosts per subnet.
30, ma'am.
32, ma'am.
Who said 32?
30.
The block size is 32,
Yes,
but two has to be subtracted, no? One is the network ID, last
Yes,
is the
ma'am. Yes, ma'am. Yes, ma'am.
broadcast ID of the host subnet.
120. 128, ma'am.
What?
192.168.10.128, ma'am.
128. No.
10.31, madam.
Very good. And if I will ask you the broadcast ID of the fifth subnet, can you please tell me the broadcast ID of the fifth subnet?
159, ma'am.
159. How you calculated?
Number of subnets is brought to 8, ma'am. Each
Okay.
subnet we have that. Each
Each subnet
subnet
has-
we have 32 IP address, ma'am.
Okay.
So then
Your,
6.
your answer is wrong. Dot one. You told dot 159, right?
Yes, ma'am.
No, dear. I don't know how you are calculating, but my way of calculation is I calculate the block size, which is 256 minus 224, and which comes out to be
Ma'am,
32.
it's not 159, ma'am. 191.
32 into 4 gives you 128. See, it has to be in multiples, right? So leave this block size. Calculate like this, no? First subnet will be 32 into 0. Next will be 32. Next will be 32 into 2, 64. Next will be 32 into 3. What? 96. Next will be 32 into 4, 128. So 1, 2, 3, 4, 5. Fifth subnet. I asked you the fifth subnet. Okay. So 0, 1, 0, 1, 2, 3, and then what is this? 128.
Yes, ma'am.
Okay. ठीक है.
120 network ID.
Right. So next is 32 into next. Add 32 to 128. What you will get? 160. ठीक है. Dot 159 is correct. ठीक है. This is fifth subnet. ठीक है. चलेगा. Good. So let me give you one more task. 10.0.0.0 slash 11. 10.0.0.0 slash 19. 10.0.0.0 slash 27. Can you please tell me the subnet mask? I need the subnet mask of all three. And I need the broadcast ID of all three. Go ahead. Do it. Take your time. Because my switching labs and upcoming routing labs will be all based on this. So I don't want to take any kind of a risk. That's why I'm revising it again.
Ma'am,
Mm-hmm.
for first one, 255.224.0.0 subnet mask.
Okay. Second one.
255.255.224.0.
Very good. Next.
255.255.224.
Good. Broadcast ID of all three.
For first one, 10.31.0.0.
10.31.0.0.
225.225, not 0.0.
225.
Second one, 255, man, not.
Ah,
Sorry,
right.
255.255.
Right. And what about the second one?
10.0.31.255.
Okay, correct. Next one.
10.0.0.255. 0.31, man, not 255. Last one, 31.
हाँ ठीक है चलेगा ठीक है correct है. Who else
Okay.
has the difficulty here? Anyone has the difficulty in understanding? Please clarify it here itself. Okay. Correct. So this is correct. Okay. So we have the subnet mask here 255.224.0.0. This is 255.255.224.0 and this is 255.255.255.2. Broadcast ID will be 10.31.255.255. Broadcast ID will be 10.0.31.255. 10.0.0.30. So we are good. Now if I will, so all are good till here, everyone. All are good till here.
Yes, ma'am.
Good. ठीक है जी. 10.1.255.255/11. Is it a valid IP or a broadcast IP or a network ID? A, B, C. Check box.
Valid IP, ma'am.
Rest of the people.
Valid IP.
Very good. So when and what about this? 10.2.0.0/11.
It's also valid IP, ma'am.
Yes, both are valid IP. Very good. So we are good till here. Good. All of you are okay till here? What are the protocols at the network layer? What are the protocols at the network layer? IP, ICMP, ARP.
ARP.
Yeah, very good. RARP, proxy R. IP is your internet protocol. You know it's version 4 and version 6. Right? Right? It is a 32-bit in version 4 and 128-bit in version 6. Right? ICMP for all messages in the network. Whether your destination host is unreachable, I'm getting 100% ping response from my destination, it's ICMP. Address resolution protocol. What it does, it's very important. That's why I'm discussing. What ARP does, IP to MAC. See, whenever I talk about MAC, MAC is the hardware address. It is an original address, right? So it is an address which has to be there with any PC or router or a switch interface. Why? Because that is a hardware address. IP is a logical address which has been assigned or designed by you, by us. So why? Because MAC is hexadecimal. I cannot remember A.1234.123. No, I cannot. I have million number of machines and the devices in the entire world. But IP, I can remember. 192, 168, 1.1, 1.2, 1.3. I can. It's easy. So I have created an IP so that for my own ease of the troubleshooting, for my own easiness. So anytime whenever you give an IP, by default, the request has to get a MAC. If I don't have a MAC, I'm out of the communication. I cannot be a part of network. Everyone got it? So whenever anyone has to go to destination IP from source IP, it resolves the destination MAC and it gives it to this source IP. Right? Everyone? This is MAC to IP. This I will tell you later. Right? So I will share a book with you today. In that, OSI model is explained very nicely. You will find a lot of protocols with the port numbers and all this stuff which I have explained. So now let's start with the switching. As I think that you have done with the OSI model and the IP addressing a lot. So what is a switch? Switch is not like as a home switch or the electricity switch. Switch is very much a hardware device. Which is very much a hardware device, right? Which has the ports, right? The ports can be 100 Mbps speed, 10 Mbps speed or bandwidth, 1 gigabit per second, 10 gigabit per second, 40 gigabit per second, and 100 gigabit per second. But generally, in an environment, you will find 100 Mbps or 1 Gbps, right? So it is a hardware device which has the dedicated number of the ports in it. Now, what a switch does basically? So switch generally, you might have heard that it makes a local area net. Switch, what it does, if you have 4 PCs, 1, 2, 3, 4. I have asked you to get a switch and connect 4 ports to it. 4 PCs to the 4 ports. The port numbering is always F0/1, F0/2, F0/3, F0/4. And I have asked all of you to give an IP to your PC. You know how to do it. Source MAC is A, source MAC is B, source MAC, MAC. These are the MAC of entire PC. Now, what is the task? I have asked you to send a file, transfer a file from A to D, right? So, what is the first thing you will check? The first thing you will check is from PC A, can I ping PC D? That means from PCA, you don't know the MAC, but I'm just writing it down, right? You don't know the MAC. Every system has its own MAC. So I will sit at my PC and I will try ping 192.168.1.4. Will you do it or not, everyone? You will sit on PCA and you will give this command, or no? You know, everyone please respond. Everyone knows what is ping? Ping is a command line which says that how I can go, touch and come back. Ping is a command for the reachability. So a system A is going to have the reachability till system D. I will check it. If I get it, then I'm good. If I don't get it, then I will drop the request. So it says go, touch the system and come back. So he will give a ping. So he will make a packet that my source IP is 1.1, my destination IP is 1.4, my source MAC is A, but I don't know the destination MAC. This piece. This request is known as ARP request. Why? Because if I have to transfer the file to this PC, I need to have its original MAC. Please get me. So this PC will generate an ARP request. And this is the ARP request. This will be heard by this guy switch and he will transfer it, forward it to all the ports. He will forward it to all the ports. This will drop, this will drop. Since the request was for 1.4, he will reply with his destination MAC, which is D. This PC will update its ARP table that I have a recent communication with 1.4 whose MAC is D and the timer is 420 seconds. Within these 420 seconds, if again A needs to send a file to D, he knows the destination MAC, D. He will put the destination MAC and he will transfer the data. But in case if he doesn't know the MAC, he will always generate an ARP request to get to the destination. Is it okay, everyone? So basically, what is a switch? Switch is a layer 2 device. When we say it is a layer 2 device, that means it has only MAC understanding. It can only understand MAC. It doesn't understand any IP. It makes my local area network. It makes my local area network. Right? It has number of ports. It can be 24 port switch. It can be 48 port switch to which the PCs are connected. It can be 96 port switch. Every port has a bandwidth. Each port has a bandwidth or speed associated with it, which is 100 Mbps, 1 gig, 10 gig, etc. Any doubts here? Any doubts?
No, ma'am.
Good. One more thing I would like to tell about a switch is a collision domain and broadcast. See, earlier what we used to have hub. After some time we have the manufacturing of switch and bridge. Right. Now what was hub? Hub is again like a switch, but it doesn't have no intelligence. Intelligence is something, if I will ask you, okay, are you going to have a cache or are you going to remember the things which I'm telling you? So you will say, yes, ma'am, we will remember. It's intelligence. But what if I will keep on telling you again and again the same thing in my lecture? It is, you just listen, you forget. You just listen, you forget. So hub is like that, right? So what is the listening and learning thing? So this comes up with the intelligence. It says, I listen and learn. So it basically works on store and forward and learn. Store, forward and learn. So basically, what is intelligence here? See, I have a hub. Hub again has limited number of ports. It cannot be more than 10 ports, unlike switch. It has the PC here and PC here. Now this PC is A, this PC is B. The IP was 1.1, the IP was 1.2. 1.1 needs to communicate with 1.2. What will happen? This hub will broadcast, it will flood, it will flood. Why? Because this is the ARP request. It says, I don't know B. It gets transferred to hub. Hub will flood it to everyone who's connected. It gets the ARP reply and he will send it to this guy A. So every time he is going to do flood and learn, flood and learn. So no cache. So, unlike switch, which was remembering this entry for at least 420 seconds. Right? Do you get it? Again the same scenario. 1.1 MAC is A, 1.2 MAC is B. It is same. It has to transfer the file here. He is generating an ARP request. ARP request says I am 1.1. I need to go to 1.2. My source MAC is A, but he doesn't do the destination MAC. So he will replace it with the FFFF. Flood. This FFFF is a broadcast. So he will generate, switch will listen, switch will flood it to all the ports. And he will get the destination MAC of B, which A will store, right? But since there is an intelligence, see, PC can store it for 420 seconds here as well as here, right? But every time hub doesn't have any intelligence. Hub is just listening the request and it's flooding. Listening the request is flooding. Every time hub is flooding. Whereas switch, it maintains a MAC table. MAC table is like a cache that I have a recent MAC learned on A as well as B. So it maintains this table for 300 seconds. So once it will flood and then it will learn and then it will unicast. It will not broadcast. Unicast is 1-to-1. Right? So it maintains the timer. It says, oh, there was a recent communication. I can hear B. I know A. So I can unicast. I can directly transfer. I don't have to flood. And I don't have to, because flooding mechanism is going to occupy the bandwidth. Every time I'm flooding, just flooding, it hogs up my bandwidth. So hub acts like as a repeater. So whenever you see that we have to have a repeater in my network, I place a hub. So you don't maintain an intelligence. Whenever a signal is coming to you, you just repeat it. Why? Repeat it in the form of a flood. Right? Switch says, once I know, you don't need to tell me and again and again. I'm there maintaining that entry for 300 seconds and I'm going to unicast the packet. Everyone got it?
Yes, ma'am.
Good. This flooding is known as broadcast domain. Broadcast domain. If I am a 24 port switch, my broadcast domain is 24 ports. It has all 24 ports. If I'm a 48 port, I'm going to flood it to all 48 ports where 48 servers are connected. If it is a 96 port, it's all. So as long as my number of ports keeps on increasing, my broadcast domain keeps on increasing. So it has both has a single broadcast domain. Every time it is flooding, but it is flooding for some time and it maintains. But still, if it doesn't know the entry, it will flood and learn. So single broadcast domain. Both. Whereas it has a single collision domain too. Collision domain means if I am 10 Mbps or 100 Mbps, right? This whole 100 Mbps or 10 Mbps gets shared with all the systems who are connected with me. So single collision domain. The efficiency of this hub, the response time of this hub will be very less. It takes time to respond to the source, right? Whereas everyone here, every PC has its different collision domain. They have the dedicated pipeline. So if it is a 100 Mbps switch, every system has 100 Mbps bandwidth or a pipeline dedicated to it. So A has 100 Mbps, B has his own 100 Mbps, whereas A and B were sharing 100 Mbps. Got it? Got it, guys? Everyone? Everyone? What is collision domain? What is broadcast domain? Broadcast domain is broadcasting within all the ports which are connected to me. Collision domain is like a pipeline, right? So let's talk about a switch. As the hubs are no more into use, switches are only used. So if system A, B, C, D, they are connected, right? So, and this is a 100 Mbps ports, all ports are 100 Mbps. Then a switch has a single broadcast domain. Why? Because I don't know the destination MAC. Every time I know that I know my source IP, I can always remember the destination IP, but I cannot remember the destination MAC. So every system who has to transfer some data to the destination will has to get the destination MAC, right? So single broadcast domain, but different collision domain. That means different collision domain. That means every system has 100 Mbps pipeline. It's like a pipeline collision domain. So no data gets collided. Hub, all the data was colliding with each other because of a single pipe which was allocated to all the PCs. That's why the sharing bandwidth was there. Got it?
Yes, ma'am.
Good.
Yes, ma'am.
Very good. Good. Herein comes up with the concept of VLAN. Now, since you have done the submitting and you are all good at it, what are VLANs? VLANs are is like a virtual LAN, virtual local area network. And what is the need of it? What are the benefits of it? Benefits, what is virtual LAN? See, whenever I have a switch, let's say 1 till 24 ports, all the PCs who are connected with the switch, all the PCs who are connected with the switch, they are a part of a common LAN, which is known as a VLAN. Right? They are the part of a common LAN, which is known as a VLAN 1. Right? But now let's assume that what we have in our environment, we have a switch, and we have, let's say, some people sitting from IT team, some people sitting from finance team, right? Let's say I have two people sitting from IT, two people sitting from finance. The IP was 1.1, 1.2, 1.3, 1.4. MAC is A, B, C, D. Now let's say finance guy 1.3 needs to talk to 1.4. What will happen? What is the first thing this will generate? This will generate an arc. Everyone. This will generate an ARP. It gets flooded to all the systems, right? So what will happen as a result of which these IT guys are going to do a packet capture of all the finance. What is happening inside the finance? So it is a security breach. So we divide the local area network into the different local area networks, different LANs, logical LANs, which are known as virtual LANs. So now what will happen because of that? I have a switch to increase the security. I have few ports dedicated to VLAN 10. I have few ports 5 to 8 dedicated to VLAN 20. So I can divide different local area networks so that security increases. How security increases? Whenever there is an ARP request which is generated by the system within this domain, this broadcast flood will be limited in this domain. It will never get here. No. That's the beauty of creating the different local area networks. Do you get it?
Yes, ma'am.
Good. So second, reduces size of broadcast domain. Earlier, this request was going to 24 ports. Let's say I have a building in which the first floor, second floor, third floor, fourth floor, lot of floors are there. On first floor, only 5 people of IT are sitting. 6 people of finance are sitting. 7 people of marketing are sitting. Right? So what I'll do? Am I going to connect 3 different switches on the ground floor where these different teams are sitting? No. This will increase my cost. I have to buy 3 devices separately. Or no? Right? So for that, we will divide the full 24 ports into the different local area networks so that my security increases. It reduces the size of the broadcast domain, right? And what else? These are the two main benefits. It logically separates the LAN. It logically separates LAN into VLANs, virtual local area. I am scalable. Scalable means whatever the number of the PCs I want to connect to a particular switch, I can do that. I am flexible. Wherever on which floor I want to go and sit and connect my system to the switch, I am good to work. I can sit on ground, first, second, third, till 10th. I can sit anywhere because everywhere on all the floors there is a switch which has my local area network. Right? Everyone, these are the benefits of VLANs. Got it?
Yes, ma'am.
VLAN is 12-bit. That's why 2 raised to the power 12 is 4096. So maximum number of VLANs can be 4096. Starts from 0 till 4095. Right. You cannot create more than that. Out of this, VLAN 1 is admin VLAN or default VLAN or native VLAN. VLAN 2 till 1001 are standard VLANs. VLAN 1002, 1003, 1004, 1005. These are reserved VLANs. Reserved VLANs. From 1006 till 4095, these are extended VLANs. Extended VLANs. Okay, everyone.
Yes, ma'am.
Now, if I will show you a switch, I will show you on the packet tracer, there is a simulator. I will give you this simulator. I will upload it on your classroom portal, and you can download it from there, and you can install on your laptops, right? Let's say we will be connecting 4 ports to the switch, and this will be a switch. This will be connected to another switch, which again has 4 systems. You can assume it as a ground floor and first floor. This is switch number 1. This is switch number 2. The port which carries these are known as 0/1, 0/2, 0/3, 0/4, 0/1, 0/2, 0/2, 0/4. This is 0/5, 0/5. These ports which carries the multiple VLAN traffic together are known as trunk ports. Trunk ports. And these ports which are connected to the servers or PCs are known as access ports. So a trunk port is responsible for tagging the traffic. Tagging. See, how can this switch tells other switch or a router that this particular traffic belongs to VLAN number 10? So that is the role of the trunk port. And what is the protocol? Is .1Q. This is the protocol which is responsible for tagging, and it always enables as a trunk port. So let's say these two PCs belongs to VLAN 10. These two PCs belongs to VLAN 20. These two PCs also belong to VLAN 10. These two PCs also belong to VLAN 20. So this will be your lab number 1. Guys, please take a screenshot, everyone. Please take a screenshot. राजीव सर आप हैं क्या? Okay, guys, please let me know how to upload it on the classroom portal. Showcase it. Where to upload? This one. Everyone. All here? Anyone here?
You want to post questionnaire or?
Yeah. Yeah. No. Not questionnaire. I just want to post this one. The screenshot.
Acha, okay. So maybe you can just save it and then you have to post it on that actually. You can save it and then what you can do is open it again, that classroom.
Wait. Sir, wait. So what I'm doing, I want to upload it from my mobile only.
Acha.
So let me
So you
check.
can take a snapshot and then in the
That's what I'm doing.
there's an option there. What you want to say something, the option of attachment will come.
I'm showcasing you my screen now. So here where announce something to your class. This one.
Yeah, announce something to class. Yeah, this one.
Achha, and this is the attachment,
exactly.
right?
Here you can get the attachment, and all students will get it. You attach that snapshot, or if it's on net, you can attach the link also.
Yeah. Wait. No, it's not on net. It's gone by me. Let me send it to my
Save
email.
your file first, and then say click on this link file, and then you upload that.
I'll be sending you one. I'll be sending you one this packet tracer file, guys. This is a software. You have to install it on your laptop. So I am uploading it. You can see this. I'm uploading it on your drive. So you can download it and you can install it on your systems, everyone. Once you get installed on your systems, then further things I will let you know what to do, right? And one assignment I'm sending you, so that one thing I'll be one time I'll be showing you, and then you are good to go with that. So we'll do a couple number of the labs related with the switching. And nowadays switching is very important, because we are moving ourselves on the clouds. You all know that we are working on the cloud platform, and cloud is nothing but the data center. So I'm going to drag you down across all the steps, but why this is important, that's the main basic I want you to know. So switching is really very important. So if you are going to build up your career in network or the software development for the network, definitely everything is on the cloud. So switching, the backend is all switching. It's all switching. So it has to be very good, right? राजीव सर, ये गूगल ड्राइव से भी लोड कर सकते हैं ना मैं अपनी?
Yeah. If you have already in Google Drive, just share the
तो
link.
I have actually. तो मेरे को फिर अब ध्यान नहीं रहा, बट अब मैंने अपलोड कर दिया. So I have.
Yeah. Otherwise, you just give the link, then it's already there.
ठीक है. तो एक मैं लिंक भी I am also sharing with you for the PDF as well, right? So I'm copying the, है ना? So I'm sharing one
just
PDF.
share the link here, they can download. Yeah.
Okay. So announce. This has been uploaded. So I'm sending you Cisco Packet Tracer. This is the tool for the upcoming labs. So this is going to cover all your course. Cisco Packet Tracer version. It is a freeware tool even. Right now the version is 7.0, but this is much more easy for you to understand. So that's why. So one thing I'm posting is Cisco Packet Tracer. So everyone please download it on your system. So it's gone, I think, right? So please access it and download it on your system. And once you will download it on your system, this will be appearing you like this here. Where is that place? This one. Can you see this, everyone? It will be an envelope like thing. So you will click it, it will get opened like this, Cisco Networking Academy. So this is the tool we all will be working on. This is the switch, right? If you will see the switch, it appears to you like this. So this is a very old switch, but right now all the switches has 48 ports. So 24 ports up, 24 ports down, right? So no switch comes up with the 24 ports nowadays. So if you will get it, it has a lesser number of ports, it is less costly into the market. But generally you will find that the switches in the market, you have a lot of vendors into the market for these devices, and it starts with the 48 ports nowadays, right? So these are the ports. Can you see the ports? 1, 2, 3, 4. From here, your Ethernet cable. I don't know who has taken your OSI model, but he might have explained you that we have Ethernet cables, and you have also seen that when you are going to connect that cable to a RJ45 port or your LAN port in your system, that's an Ethernet cable. So you connect that Ethernet cable on one port and connect it to the LAN port of your PC. So that's how you make your local area network, right? Can you see 10, 100,000 basically? So these are the speed of the ports that it can support till 1 gig, right? So by default, you will find 100 Mbps ports, 100 Mbps, 100 Mbps, 100 Mbps, right? So here, Let me check. Yeah, here it is. So I have to give you the lab of. So I will see that it's there into the download. I think it's there into the downloads now. Downloaded it. Let me upload it for you. Announce something. Has anyone download this packet tracer installed on your laptop? Everyone? This is, I think, Drive, right? Packet tracer.
Yeah, this is your drive actually.
Sir, ये
Link is this one, right side one. Yeah, add link. You just paste it here. Your drive link.
अच्छा, no. I just want to upload something from my system to here.
Achha, then you have to click on yes, upload file. Yeah, the second one.
The second one I'm
Yes,
doing,
it's
but it
upload
is getting me into here. My drive upload. Okay.
That's okay. यहाँ पे browse and
हाँ, ठीक है, ठीक है.
click from computer.
ठीक है सर, ठीक है. डाउनलोड में गए. Everyone, this will be your assignment, but understand first of all that what we have to do here. This is the layer 2 switching lab, right? Post. So everyone, do one thing. Please take a screenshot. Please take a photo of this. Please take right now and put it on your mobile. Though I have uploaded the same thing in your in your classroom, right? Exactly. So we are going to implement this lab. See very carefully. I'm going to send you down the configurations, right? That you understand it first of all, and then I'll be sending you the configuration. So see the configuration, install the packet tracer, and then practice it for the next week. And then I'll see you in the next week, Saturday, right? So have you taken the screenshot of this, everyone?
Yes, ma'am.
Yes. So let's go. What we are going to do, going to get into the packet tracer. You have to open the software. You have to open the software. You have to open the software like this. And these are the switches: 2950, 3650, 2960. So you have to drag and drop 2950 24 port switch, right? Then you have to take the PCs 1, 2. I'm doing as per your screenshot. So see very carefully. 1, 2, 3, 4. Now I have to connect a port. So the first come, first serve. If I'm connecting first system, it is port number 1. I'm connecting second system, it's port number 2. I'm connecting third system, it's port number 3. Fourth system, it's port number 4. First system, so it's an automatic connection. Why I'm doing it? Why? Because I have to connect the system. And why I'm doing like this? Why? Because I have to obey the diagram. I have to be as per my diagram, right? Where I'm connecting the port number 5 to port number 5. Can you see? Port number 5 to port number 5. Everyone? Good till here? Understand the command line? This is known as the command line interface, CLI. Command line interface, and this is Linux based system. You enable, this is known as a user mode. This greater than is known as user mode. You get into enable, you come into privilege mode, you get into the configure, you press a T key tab to write down the whole command. You can give a host name, switch 1. See, the host name changes to switch 1. You can define, okay, right now, exit to come out of it. Show VLAN brief. You can see all the ports belongs to VLAN number 1, which is an admin VLAN or a default VLAN. I have 4 reserved VLANs, which you can see for the older topologies. Right now, no VLAN, nothing. All 24 ports belongs to VLAN 1. There is no VLAN 10, no VLAN 20, no trunk port. Everything is 1. Similarly, we will see the output of switch 1, the other switch. Right? It is again a 24 port switch. I get into the CLI, enable. Sir, this is recorded, right? This is getting recorded.
Yeah. So they will get a recording on that same classroom only, so they can
No problem.
repeat and
So,
see.
right, very good, sir. Okay, perfect. So everyone, please have a look at the command, and then you can practice these commands at your home, like when you will meet next time, right? So we can configure a host name. You can press exit. Just want to come out of it. Show VLAN brief. So right now for switch number 2, again belongs to VLAN 1. Configuration. We will create a VLAN 10, name X, exit. To come out of it, everything has to be into the configuration mode. Name Y, exit, come out of it. What if you have to configure anything? You have to be into configuration mode. If you have to show anything, like whether it has been done or not, then you will say show VLAN brief. So I have 10 and 20 created, which earlier was not there. Similarly, I'll get into switch number 2. We'll get into the configure. Press tab to write down the whole command. VLAN 10, name X, exit. VLAN 20, name Y, exit. Control plus Z key to come out, show VLAN brief. 2 VLANs we have created. But right now you will see the topology. First and second port belong to 10. Third and fourth port belong to 20. Everyone, okay till here? Okay till here, everyone?
Yes, ma'am.
Okay. So as per my diagram, the first 2 ports belongs to VLAN 10. Interface, range means continuous range of the ports, 1 to 2, switch port, access, VLAN 10. This is your assignment, what you have to do. I'm just guiding you right now here, but you have to do it. Interface, range, F0/3 to 4, switch port, access, VLAN 20. What I'm doing, I'm making first 2 ports as a member of 10, next 2 ports as a member of 20. Exit to come 1 step back. Interface F0/5, switch port, mode, trunk. Now you are trunk, right? Switch port, trunk. Why? Because you are going to carry the tagged traffic to switch 2 as per your diagram. Same configuration I will do in switch 2. Get into the configure, terminal, interface, range, F0/1 to 2, switch port, access, VLAN 10, exit, interface, range, F0/3 to 4, switch port, access, VLAN 20, exit. See, why I'm not making a trunk on switch 2? I should have made a trunk on switch 2 as well. But since the ports of the switches are in the auto negotiation mode, if I'm configuring a trunk port here, this will automatically become trunk because it is auto negotiation mode. So let me check switch 2 whether the trunk port has come up or not. I have not configured here. Show interface trunk. See, the port number 5 is auto mode and the trunking is on and it allows all the VLANs. Everyone, okay till here? Similarly, I will get here, show interfaces trunk. I can see the trunk. Show VLAN brief. I can see first 5 ports are no more than members of VLAN 1. First 2 ports belongs to 10. Next 2 ports belongs to 20. And fifth number port is no more visible here. Why? Because it is a trunk port. So the status of the trunk port I can check with this command. You can press tab everywhere to write down the full command. How to save the configuration is WR or copy running config. Running config is whatever we are doing into a startup config. It is a by default file in your switch as well as router where the configuration gets saved. So by default Cisco gives it. So it's saved. Right, everyone? Either you WR or you say copy running to startup. So you have to do this. Any doubts you have here, please ask. So I will be sending you this file too as well, so that you can have a reference to the file. Have you downloaded the packet tracer on your system space? Have you uploaded this? Sorry, have you downloaded the packet tracer or not? So here I'm going to load switching lab number 1. This is your day 1.2 file from me. So, okay, do you all get to know what we have to do? Everyone.
Yes, ma'am.
So, have you installed the packet tracer?
Yes, ma'am. Just now downloading.
Just now downloading. Okay. Is everyone done? Please let me know. So what you have to do, let me announce it to the class now. What you have to do, right? Lab switching basic, right? So connect to switches back to back as per topology. Configure VLAN 10 and VLAN 20 in before the switches where the inter switch link as trunk port. Right now you have to do this only. Apart from this, you can configure the IP pool for VLAN 10 as 10.1.0.0/24 and configure the IP pool for VLAN 20 10.2.0.0/24. Next, insert PC communication intra VLAN. Intra VLAN means within the VLAN, right? Communication should within the VLAN. So this is your lab, and I am again going to upload it, right? The same image which I have uploaded a way back. Downloads image. So this is the assignment you have to do for this week, right? So you understand, try to figure it out. Right now I have shown you the configuration and the video is being recorded. VLAN 10, right? VLAN 10, how to give the IP to the PC, go to the desktop, go to the IP. Since the IP pool was 10.1.0.0, so it is 10.1.0.1 255.255.255.0. I don't need to specify a gateway because this is within the same VLAN. 10.1.0.2 255.255.255.0. 10.1.0.3 10.1.0.4. I hope you are understanding it. Everyone, please respond. Don't sit quiet. I'm just giving the IP. These two belong to VLAN 10. These two belong to VLAN 10. Now these two belong to VLAN 20. So from the IP pool, I'm giving an IP 20 dot, sorry, 10.2.0.1. 10.2.0.2. 10.2.0.3. So you have to test the intra VLAN. That means VLAN 10 can talk to VLAN 10 and VLAN 20 can talk to VLAN 20. Ping 10.1.0.2. It's pinging. Ping 10.1.0.2. It's pinging. So you can press up arrow key to repeat the whole command. So intra VLAN for VLAN 10 is working. So let's ping for the other VLAN. Ping 10.2.0.2. 0.2. It's working. 10.2.0.2. It's working. This is the practical, so you have to do it. That's it. Right? So will you try this?
Yes, ma'am.
Okay, so this is your assignment for the next week. Get ready for this, how to draw the topology, how to connect the switch. I have shown you in the recorded video, so you can see this video and you can do this. So this is the assignment for you. Got it? So close करें session फिर. Rajiv sir. Till then, you have any doubts, you can ask me. This is the switching lab for today. If you have any doubts till then, if you can practice, I will guide you. Or otherwise, you can see the recorded session and you can see the command lines what I'm doing. If you have any doubts, you can come back. Otherwise, we'll close the session for today.
So Aparna, it's over for today, or anything is left?
Yes. It's over for today. So this
Yeah,
is a simple lab. They have to build up. Then only I will start ahead.
Sure. So
And
guys, as ma'am told, please go through the lab, download your lab, go through the exercise, and keep your queries ready, or you can reply on those links which you have received. We will check it and try to reply as many as possible. Still, if some queries are left, then we will take it up in the next class, and at least try to finish your lab, before that. And once you finish your lab, please attach the snapshot of that lab in the assignment.
one more thing, I am sharing the CCNA PDF link here. So OSI model, IP addressing, and then you can get into the chapter number switching. Like I think it's a 7th chapter or an 8th chapter. You will get the command line and very basics of the switch. You can read it. So let me post it first of all. You can drive it. You can download it. So let me show you, sir. Sorry for interrupting, but let me show
No, okay, that's okay. Please go ahead.
See, I'm just opening this. This is the book which I have shared with you. So this is an older version of CCNA, but it is very, very good. It is very easy and very easily able to understand. Right? So you can see we have to go via chapter number 1, 2, 3, 4. Not 4, 1, 2, 3. So go with the chapter number, okay, 4. Fine, no problem. So this is iOS. No, don't go via 4. So you have to go via 1, 2, 3, and then directly go with the virtual LANs, chapter number 9. Right? So what we have to do? We have to go with the chapter number 1, 2, which covers your OSI and TCP/IP model. Chapter number 3, if you are good at IP addressing subnetting, you can leave it, or you can see the questions at the back side of it, right? And go directly with the chapter number 9, which is a VLAN. So VLAN basics, VLAN memberships, identifying VLAN. You don't have to go with VTP. So till here, just read what are the VLAN basics and all, right? So I have shared this book with you. Got it, everyone? So please go ahead. It's done.
Yeah, I think you covered